Imagine that you have a graph, y equals the square root of x, which we know looks like the picture in the cloud, and it's translated 3 units down and shifted 2 units to the right. So you're looking at this graph, you go, wow, it looks like this basic graph, but it's been moved 3 units down and moved 2 units to the right. What is the equation for this? Well, we would take the basic equation, y equals the square root of x, and we would deal with shifting 3 units down by subtracting 3 outside of the evaluation of the basic function, y equals the square root of x, and then minus 3. And finally, to represent the shift of 2 units to the right, we would go within the square root, in other words, within the evaluation of the basic function. And since they want us to shift right, we would subtract 2 units. So the final shifted equation would be y equals the square root of x minus 2, and then outside of the square root, minus 3. Now, next example. Start with a graph of y sub 1 equals the square root of x. Okay, we know what that looks like. Again, it has a point at the origin. It moves off to the right as it rises. The domain, the x values are everything from 0 with a boxy bracket. It includes 0 out to infinity with a round bracket. The range is all the y values that start at 0, then they move upward. Boxy bracket on 0 because we include 0 all the way up to infinity with a round bracket. From that start of y sub 1 equals the square root of x, they want us to sketch the domain and find the domain and range of this variation. Y sub 2 equals negative square root of x plus 2, and then outside of the square root, minus 4. Well, the negative sign in the front of the basic variation of the basic function tells me we're going to reflect our picture that we drew over here in the beginning, reflected about the x-axis. So let's turn this picture up here upside down, reflected about the x-axis. Then the 2 being added to the x says that we're going to shift to which direction? We're going to shift left 2 units. So take this point at the origin, shift it 2 units to the left, and draw the same graph. Next thing we do, because of the 4 being subtracted outside the evaluation of the function, we are going to shift downward 4 units, this point that we had, 1, 2, 3, 4, and then draw the same function. Now looking at this picture in the box, we can determine the domain. X values, the smallest x value corresponds to negative 2, and since this is a solid circle, it is included in the graph, so we get a boxy bracket. Largest x value associated with this graph would go all the way to infinity with a round bracket. The range are the y coordinates. The smallest y coordinate, well, this thing keeps dropping down forever, so you could drop down all the way to y equals negative infinity. But if you move upward, you'll see that you'll have points somewhere on this graph all the way up, and including y equals negative 4, boxy bracket.